Let's talk about the surface area of pyramids and cones. We've talked about the different parts of our solids, and so hopefully you remember that the vertex of a pyramid is the point that's opposite the base. The base of a regular pyramid is a regular polygon, and the lateral faces are congruent isosceles triangles. The slant height is a new term. It's the height that goes from the vertex to the midpoint of the edge of the base. The altitude of a pyramid is that perpendicular segment from the vertex that goes straight down to the center of the base and is perpendicular. So make sure you're paying attention to whether you have a slant height or the height or altitude of the pyramid. Here are the formulas that are on your formula chart for the lateral and total surface area of a regular pyramid. So let's apply these. We want to find the lateral area and the total surface area of a regular square pyramid with base edge length of 14 and a slant height of 25. Well, to find the lateral, it's 1/2 perimeter of the base times the slant height. This L involving surface area is referring to the slant height, not the length. So don't get that confused with area of a rectangle. So if we come over here and make our list, P is the perimeter of the base, and since we have a square base, I'm going to draw it just so I can kind of picture it. We know it's a square, and the side lengths are 14. So the perimeter would be 14 times 4, which is 56 centimeters. The slant height is given to us of 25, so now all we have to do is substitute in. And we get that the lateral surface area is 700 square centimeters. Let's find the total surface area. Noticing that this first term is our lateral surface area. So we already know what that is and we can substitute that in. This big B or capital B here is referring to the area of the base. Well, we have our little side work, and since our base is a square, we know we have side squared. So 14 squared is 196. So we want to add 196, and we get that the total surface area is 896 square centimeters. Notice it is important to write your formulas as you see them on your chart and to make a list of the variables that you are using. It's also helpful to draw the base in case you need to use any other formulas to find the area. Now this one will be due in class. Remember to follow the red dotted line since it goes from the vertex to the midpoint of a base edge. This red dotted line is your slant height. So pay attention to that and notice the shape of the base being a regular polygon. So find the lateral and total surface area of this regular hexagonal pyramid for class. Let's look at cones. The vertex of a cone, very similar to a pyramid, is the point that's opposite the base. The axis of a cone is the segment whose endpoints are the vertex and the center of the base. This is also known as the altitude or height of the cone. Slant height, notice, goes from the vertex to the edge of the base. So it is very similar to our pyramids. We're going to focus on the right cones, so let's look at our formulas for these. These are the formulas from the formula chart. I will make note that this total surface area can also be seen as pi times radius times L plus R. Notice that each term here has a pi and a radius, so we factored that out and we're left with the slant height plus the radius. It does not matter which one you use, but just so you know, I will be using this one over the other one. And look at the net of this cone here. The slant height is this distance here. So let's use these formulas. We want to find the lateral and total surface area of the cone. So our lateral formula is pi times radius times the slant height. So making our list, our radius is 8 inches. Our slant height we don't know, but we're given the radius and we're given the altitude, which does make a right triangle, so we could use Pythagorean theorem in order to find the slant height. And in this case, we will get 17. So now when we plug in, substitute in, this is what we have, and leave your answer in terms of pi to get 136 pi square inches. That is our lateral surface area. Now for the total, we have pi times radius times the slant plus the radius again. We are using the same variables, so we already know our information. So pi times 8 times 17 plus 8. Simplify your parentheses, and we get that the total surface area is 200 pi square inches. This one here is due in class. Remember to write your formulas down, make your list of variables, and substitute in accordingly. So now let's look at this one. We have a hexagonal pyramid here, and we want to describe the effect on the surface area when the dimensions are both divided by 5. So if you remember, our surface area times the scale factor times the scale factor will give us that new surface area. All we want to know is the effect, so we're going to focus on this part. Our scale factor here is 1/5 since it says to divide by 5. So when we have 1/5 times 1/5, we get 1/25. So we know that the new surface area would be 1/25 the size of the original. Here I'm telling you that the base edge length and slant height of a regular square pyramid are both multiplied by 2/3. I want you to describe the effect on the surface area and have this ready for class. Let's look at a sphere. This formula is also on your formula chart, so hopefully you're seeing the importance of having your formula chart in class. So to find the surface area of a sphere, we do 4 times pi times radius squared. So if we're given the diameter is 76, we want to write our formula. We're given the diameter is 76, so that means that our radius is 38 centimeters. So when we substitute in, we get that it has a surface area of 5,776 pi square centimeters. And again, it said to give your answer in terms of pi. So we have that symbol in our answer. This one I want you to have ready in class. It says find the surface area of a sphere with a great circle that has an area of 49 pi miles squared. This is your great circle. Your hint is that the great circle just means the area of this biggest circle around the fattest part of the sphere. So you need to use the area of a circle in order to find the radius of this sphere to find the surface area. We can also apply our formulas to find the surface area of this composite figure. So you need to look at how is this, or what is this made up of? Well, if you notice, we have a hemisphere, which is half of a sphere, plus a cylinder. And it says to give our answer in terms of pi. So first we need to find half of a sphere. So we have 1/2 times 4 pi r squared. We can simplify this to 2 pi r squared. Our radius is 6 inches since our diameter is 12, because if it's 12 here, it's got to be 12 here. So we have 72 pi for the hemisphere. Now remember, that is that total surface area of the hemisphere. We're going to have to subtract out this circle from both the hemisphere and the cylinder. So the area of the circle is 36 pi. So we want to subtract out 36 pi to where we get the the surface area of the hemisphere that we need is 36 pi square inches. Now let's look at our cylinder. Remember, our cylinder is 2 pi r times the height plus the radius. Our radius is still 6. Our height now is the 9 inches. Oh, that's a 6. So we can do 2 times 6 times 15, because we combined like terms. And we get that the cylinder is 180 pi. But remember, we don't see this circle, so we're going to subtract out our 36 pi. So the surface area for the cylinder that we need is 144 pi square inches. Now remember, we have our hemisphere plus the cylinder for this composite figure, so when we add these together, we get that the surface area of our composite figure is 180 pi square inches. It's always good to make your plan first and then label your work so you can keep your thoughts organized. This one will be due in class. Now I know it looks complicated, but your hint is that you're finding the area on the surface that you see. So think of it as this is a top, it's like a hole. There is no covering there. So even though the pyramid is inside, what part of this pyramid do you need? So make your plan, use your formulas, and organize your thoughts in order to find the area of this composite figure. Remember, there is no top here, so just calculate the surface area of the parts that we see. This is due in class.